Is our universe right now devouring other universes? What if universes can collide? Or even so, what if our universe has collided and continues to collide with other universes? It sounds quite extraordinary, and that's exactly what today's episode is about. It's Cosmo here, and you're watching Space Made Simple. That galaxies can collide with each other is not surprising. We observe many such events at various stages and in different scenarios. But how can universes collide? It's exactly the collision of universes that a new scientific article describes. Beyond the question of how, the question of why likely arises immediately. Why propose such a hypothesis, and what problems could it help solve? Thus, scientists are trying to address the problem of the accelerated expansion of the universe, the cosmological constant, and even more. And here is the article itself. So, here are the basics. First, we know that the universe is expanding. We've been aware of this for almost 100 years. According to the latest information, it's not just expanding, but doing so at an ever faster rate. And, it would seem, we have a lot of mass in the universe. So what should one mass clustering do to another? Exactly. They should attract each other. That is, on small scales, of course. Gravity wins. And, for instance, planets in planetary systems and stars and galaxies are still not flying apart from each other due to the expansion of the universe. However, on the largest scales, gravity somehow does not slow down the expansion of the universe or cause the universe to collapse back on itself. This is where we start talking about dark energy, something mysterious that opposes gravity on large scales and prevents the universe from contracting again. While the concept of dark energy is included in modern cosmological models, it has serious problems. First, we have no idea what it is. We only see its presumed effect of accelerated expansion. Its nature remains a mystery. And secondly, dark energy is associated with the concept of the cosmological constant. And the problem with this constant is that if dark energy is the energy of the vacuum, inherent to space-time itself, then theories predict one value, but the values scientists get from direct observations differ greatly from the theoretical prediction. And the difference is huge, up to 120 orders of magnitude. As I've said before, this is called the worst prediction in physics. Besides accelerated expansion, there's also the question, what is everything expanding from in the first place? Especially, why did the universe expand so rapidly at the beginning of its existence and then slow down? We're talking about a period now called inflation. I've already made a detailed video about it, and the authors of the new article proposed a version to solve these problems. The primary mechanism is the merging universe. Of course, the authors do not claim that this is exactly how things are. It's more of a mathematical exercise designed to check if such a model could align with what we observe in practice, and some details of the process are not specified in the article. First, we have to assume that other universes exist, which of course, we don't know for sure. And not just any version of the multiverse will do. I've already talked about the levels of the multiverse in this video, but the first level, where other universes are essentially other parts of our own universe that just happen to be beyond the boundary of our observable universe, is the same space with the same properties and laws of physics, just very far away. Here, the discussion is more about higher-level multiverses, about other spaces. Which ones specifically? The article does not clarify, although there are some details. I'll remind you that in some versions of the multiverse, other universes may even have different laws of physics and different values of fundamental constants. In this article, the scenario of other universes with the same properties as ours is considered. So, how is the merging of universes related to dark energy and accelerated expansion? The article's authors propose replacing dark energy with other universes. When we talk about the expansion of the universe, naturally, we don't mean a situation in which galaxies are simply flying apart from each other. No, the distance between them increases because the fabric of space-time itself is expanding. There's simply more space between two galaxies. And now, this is explained by dark energy. But what if there's more space because our universe is constantly absorbing other universes? The article even uses such phrasing as being bombarded by baby universes. Sounds fantastic, of course, but in some sense, it could be an even more intuitive explanation. At least here it's clear where the additional space comes from. Again, the specific mechanism of how this might happen is not described in the article. And here I can recall, for example, the variant in which our four-dimensional, or more precisely, 3+1 universe, is inside a hyperspace of greater dimensionality, which can contain other parallel universes. This is like brain world cosmology, which I will make a separate episode about. While a detailed mechanism isn't described here, the authors of the article developed a mathematical model. For such a scenario, they conducted calculations and claimed that this model aligns better with observational data than the contemporary accepted version with dark energy. The second application is the explanation of inflation. Essentially, why did the universe expand a huge number of times in the first moments of its existence in a brief instant? Currently, one of the explanations for this, again, is related to multiverses, but it sounds a bit different. There might exist some inflationary field in which inflation, or very rapid expansion, always continues, but for some reasons, it slows down in some places, and thus, bubbles of universes emerge. In the new article, instead of the inflationary field, they propose explaining inflation again through merging with another universe, only this time not smaller than ours, but on the contrary, with a larger one. That is, it's not us who absorbed, but our young universe was absorbed by another universe, and as a result, it appears that our universe abruptly increased in size. This all sounds very bold, of course, but on the other hand, when we still don't have a definitive explanation for either dark energy or the nature of inflation, such ideas can be considered. And then, as we obtain higher quality data, we will see which version is best confirmed by it. Thank you for watching this episode. Subscribe to the channel and see you soon. This was Cosmo, and you've been watching Space Made Simple.